Well, thank you very much for that introduction. I'm very happy and flattered to have been invited to come here. It's really great for me to have a chance to talk about my research, which I've been working on for quite a long time. And I look forward to comments, questions, criticism, and so on. I do hope we will have some time for that. And so I have 45 minutes now, and hopefully there will be some time also for questions. Okay. The theme of my talk is the public's risk perception of technology. And I should say right now that most of this work is based on work on nuclear industry or nuclear technology, nuclear waste particularly. But not only that, I also have some work on food risk, on genetically modified food, and some other examples as well. And I will end up with some data on nanotechnology also, but that has not been my major interest so far. Let's see now. Yeah. So this is the outline of my talk. I will say something about the psychometric model of risk perception, which is, of course, the dominating so-called, so to say, the received view in the field. I will speak about trust, about risk targets, demand for risk mitigation, affect or attitude and emotions, experts and the public, social validation, the attitude towards nanotechnology. Now, why should one do research on risk perception? Risk is a very common issue in policy deliberations. It seems to be getting more and more important over time, by the way. It's important both for decision makers, for experts and the public. Several risk-related issues have created great economic and political turbulence. Nuclear power is the obvious example, but there are many others. You may remember the mad cow disease and all of the problems it created in Europe. And because of this, there is a need to know more about how people perceive and react to risks. The traditional view of risk perception, psychometric paradigm, stresses some important points. It says that there are only a few generally applicable factors which determine perceived risk. The major factors would be novelty or new risk or unknown risk and dread, which are sort of decisive with regard to how the risk or a given hazard is perceived. Demand for risk mitigation is governed by the size of the risk. The greater the risk, the more people demand that the risk should be mitigated. Experts, on the other, are objective, and they're not influenced by subjective risk factors such as novelty and dread. So there is a great distinction here, a great difference between how experts perceive and assess risk on the one hand, and how people in general or the public does it on the other hand. Trust in experts and institutions is very important. If trust can be established, it will reassure the public and make them believe in and accept the experts' objective risk assessment. The social dilemma of risk management concerns different views of experts and the public, and hence research has been concentrated on these two groups. There is some work on other groups as well, but that's not very much. Most of it is on experts and the public. This is the classical illustration. I'm sure you have all seen it several times. It's from a basic paper published in 1978, actually, where it's shown how nuclear power emerges as a very extreme case. It's an unknown, uncontrollable new risk, certain to be fatal, it's dreaded, it's catastrophic. So it stands out as a very extreme case. And that could perhaps explain, so many people thought that would explain the public's extremely negative reactions to nuclear technology. However, if you look closer at these dimensions, you find that it's not that simple. For example, if you look at the variation among individuals, you find that it will explain only about the model, the two factors will explain only about 20% of the variation, often less. And most of the explanatory power is due to the so-called dread factor, while novelty has no or very little explanatory power at all with regard to individual differences. New risks are not necessarily feared or rejected. There are other factors which enter the picture and are more important. But we have to look a little closer at dread. This word suggests that the factor is a measure of an emotional reaction. Many people writing about dread also seem to have interpreted it in that way. However, if you look closely at the items defining the dread factor, you find that they do not measure emotional reactions at all, with one exception, but they measure severity of consequences. In empirical data, when you relate the dread factor to perceived risk, you do find some relationships, fairly strong correlations at times, but these are due not to the emotion item, but to all of the other items which measure severity of consequences. I think that's an important point to make. So I just said that the psychometric model explains only sort of a minor percentage or minor portion of the variation in risk perception. Now, what do you need to improve on the model? Well, we found in our research one important factor was interfering with nature. People believe that if a technology interferes with nature, whatever that means, you can of course think a lot about that and speculate about what it should mean. But anyway, that's how people see it. If it interferes with nature, the technology is seen to be risky and it's less likely to be accepted. Nuclear technology is an obvious case. Genetically modified food is another obvious case, and there are many others. So this is an important additional factor. Then trust. Trust was introduced in the psychometric paradigm in around 1991 or 92. Found to be important, but if you look closely, you'll see that epistemic trust is even more important. Epistemic trust is trust in science. People will tell you, we did some interview studies in Sweden concerning nuclear waste, and people would tell us, well, here are those experts coming up from Stockholm talking about the risk and telling us that we shouldn't be too concerned about the risk connected with a nuclear waste repository here in our community, but we feel these people seem to be competent, trustworthy, and so on, but we feel that the science behind what they say is not that final, it's not that totally trustworthy. We trust in the people and in the institutions, but not in the science. So in this way we found there was an important distinction here between the social trust. Almost all work on trust is concerned with social trust, but we found that the trust in science behind risk assessment was even more important. I've called that epistemic trust. Then there are other factors, such as perceived benefit, whether the technology brings about unique advantages and is hard to replace. This is coming to be a very important aspect on the debate about nuclear technology.